Hello, in this video, I will explain to you on how to solve this problem. Number 18. In April 1974, John Massis of Belgium managed to move two passenger railroad cars. He did so by clamping his teeth down on a bit that was attached to the cars with a rope and then leaning backward while pressing his feet against the railway ties. The car together weighed 700 kilonewton. Assume that he pulled with a constant force that was 2 times his body weight at an upward angle of 30 degrees from the horizontal. His mass was 80 kilograms and he moved the cars by 1 meter. Okay, let's see here. What can we do from here? Let's draw it, right? So because this is a physics problem, we have to draw it. Okay, so we have the train here, the train's car. Okay, and I have it like that. And this is maybe the wheel. Good. And then this one has weight of 700 kilonewton. So the weight of the train is 700 kilonewton. And then we will have he pulled with a constant force that was 2 times his body weight. So he pulled it like this here. So we have his force here. And then it makes an angle of 30 degrees from horizontal. So this one will be our horizontal. And he made an angle of theta here. Good. And then what else? His mass was 80 kilogram. Okay, so his mass was 80 kilogram. And then the force is 2 times his body weight. So I'll have the force here is 2.5 times his body weight. Okay, his body weight. So we can just plug that in. 2.5 multiplied by the mass times gravitational acceleration, right? So we'll have 2.5 times 80 and then times 9.8. And then that will be, what is it? Let's use calculator for that. 2.5 times 80 times 9.8. Okay, and I will have 1960 Newton. Okay, 1960 Newton. That will be the force here. And the angle here, that will be 30 degrees. Good. Okay, but then we need the mass of the train, right? So we will have the mass of the train is just the weight, right? The weight divided by gravity. So we will have 700 kilonewton or 700,000 Newton divided by 9.8. And that will be, what is it? 700,000 divided by 9.8. And I will have 71 for 28, 71 for 28, and then point what? 0.57. Okay, and the unit here will be in kilogram. Good. Okay, that will be the mass of the train. And I think we need to get the projection of F here into the horizontal. Why? Because we need to calculate the acceleration in the horizontal direction. So let's just find the Fx here. So Fx, and what is Fx? Fx is just F. F is the hypotenuse and Fx is the adjacent. So I will have F cosine of 30 degrees. Okay, but then we can just plug in Fx here. What is F? 1930, 1960, and then cosine 30 degrees. And we will have our Fx here. That will be 1960 multiplied by cosine 30. And I will have 1697.41. 1697.41. Yeah, 41 Newton. Good. But then we can calculate the acceleration from here, right? So because the net force here is equal to mass times acceleration, and we know the force here, right? So we will have the only force that worked on the train in the horizontal direction is this one. So we will have 1697.41. And then what is the mass? The mass of the train here will be 71. Okay, 71, and then 428.57. And this is the acceleration. And we can just use calculator to divide this by that, right? So I'll have, let's use calculator, 1697.41, and then divided by 71, 428.57. Okay, and I will have 0.024. Okay, 0.024 meter over second square. Good. And let's clean up our slide because it's full, and I think I only need this one here, right, to calculate the speed of the car. Okay, let's clean this up. Okay, now we have turned kinematics into kinematics problem. So this is the train here. Okay, and its initial velocity will be 0, right? So we will have here our VO is equal to 0 meter over second. But then some force accelerated it with this constant acceleration. And then it moves 1 meter, right? So it moves 1 meter here. So we'll have this 1 meter, the displacement. And we can just use the kinematics, right? So we'll have Vt squared is equal to VO squared plus 2ax, right? And the question is asking about the final velocity or the speed here. Okay, we can just plug the values in. So I will have 0 here, 0 squared, and then plus 2, and then the acceleration is 0.024, and then multiplied by 1. Good. And so we will have this one here, Vt squared is equal to, I think we need calculator for that, 2 multiplied by 0.024 multiplied by 1. Okay, I think I will have 0.048, but then this is Vt squared. We need to take the square root of it, right? So I'll have the square root of 0.048. And so we will have our Vt here is the square root of 0.048. Okay, and that will be 0.22. 0.22, and the unit here will be meter over second. And that is the final answer for this question. Vt is 0.22 meter per second. So the speed of the cars at the end of the pole is this one here. And I think that's all for this problem. Thank you for watching. See you in the next video. Bye bye.